Greetings, ladies and gents, and welcome back at Semi Maths and Science Club. In the previous videos, we have been looking at motion on one object only. Now, remember that we are still on projectile motion. Now, in the previous lessons, as I've already said, we have been looking at motion, in this case, on one object only. But in this lesson, we'll be taking things a little bit further, as we'll be looking at objects, at two objects which are either projected from the same height. Now suppose, let's say we had in this case a building somewhere there. In this case one will be projected. So in this case, when you say we'll be looking at objects that are either projected from the same height, so in this case both of them in this case would actually be in this case on the same height. So in this case they could either be in this case projected upwards or downwards. It really doesn't matter. And also be looking at in this case at objects, at two objects which are actually projected from in this case different heights. So in this case, suppose let's say we had again a building. All right, then suppose let's say we had an object there. Let's say that's object A, and in this case one is object is projected, let's say from that position there, let's say either being upwards or downwards. And in this case one is projected, in this case let's say that's object B. Say object B is projected in this case from in this case the ground upwards. And we'll be looking at questions such as, if one object is thrown downwards from let's say height h, right, and one object is thrown upwards from the ground, how long would they take to meet, and how far above the ground would they be when they pass each other, and what connects these two objects. And so we'll be looking at questions as such. Now, one thing that you must keep in mind is that if two objects are projected at the same time, so in this case, if two objects are projected this case at the same time, so in this case, one thing that you must keep in mind is that if two objects are projected at the same time, that would mean that in this case their time in motion at any given point, for as long as they're still moving, their time would simply be in this case the same for both objects. So in this case, if let's say object A has been in motion, so let's say we have two objects which are projected at the same time. So in this case, if object A has been in motion for 3 seconds, so that would also mean that in this case object B would also be in this case in motion for 3 seconds. So in this case, this is only applicable in this case if in this case both of them are still in motion. And in this case, if let's say object A has been in motion for 2 seconds, so that would also mean that in this case object B would also be in this case, would also has been in this case in motion for also 2 seconds as well. And the reason for that would simply be because they were projected in this case at the same time. So in this case, that's one thing that you must keep. So in this case, if two objects are projected at the same time, so that simply means that in this case, for as long as they're still in motion, time in this case for object A at any given point, in this case for as long as both of them are still in motion, so in this case time for object A would simply be equal to, in this case, to time in this case for object B. So in this case, so this is one thing that you must keep in mind. And in this case, the other thing is that if in this case one is thrown first and another is thrown second, their time in motion in this case would not be the same. So you must keep that in mind. If let's say we have two people, right, that are trying to race, right, now let me just draw my two people there. Now I'm not very good at drawing. Say we have two people there. Let's say that's person A, and that's let's say that's person A there. So let's make this person to be in this case person B. So in this case, if let's say we have two people that are trying to race, and in this case person A goes first and person B goes second, so that would simply mean that in this case person A would be in motion much longer than person B, for as long as both of them in this case are still in motion. So if in this case person A is starts running now and person B starts running, let's say 3 seconds later, so that would simply mean that in this case, whatever time person A was in motion or is in motion, right? So in this case, that simply means that in this case, person B's time in motion simply be 3 seconds less. So if person A was in motion for 5 seconds, so that would simply mean that in this case, person B would also be in motion in this case for 3 seconds less than in this case than person A. So that would simply be in this case 5 minus 3. So in this case, so at any given point, so in this case, so that would simply be also applicable. So in this case, so that would mean that in this case, if in this case, person A has been moving, let's say for t seconds, so that simply mean that in this case, time for in this case for person B would simply be in this case t minus in this case 3 seconds. So you must keep that in mind. Let's say if in this case time for person let's say person A, in this case, if that's equals to t, so that would simply mean that in this case time for person B would simply be equals to t minus 3, in this case according to in this case to the example that I made. So in this case, if let's say we have object A that was projected in this case 0.5 seconds later after object in this case B, let's say we have object in this case A, which was let's say we have object B rather that was projected 0.5 seconds later after object A, then that would simply mean that in this case whatever time ball A has, ball B would simply be in this case 0.5 seconds less for as long as both of them in this case are still in motion. So in this case, if object A has been in motion for t seconds, so that simply means that in this case object B would be in this case in motion for t minus 0.5 seconds. So keep this in mind. Although it looks a little bit simple and kind of silly, it's very important, because now what connects two objects under the influence of gravitational force only is actually time and displacement. Now let me just show you how also displacements also connect in this case two objects. Right now, suppose let's say suppose let's say I was standing in this case at the edge in this case of the building. Let's say we have a building there. We just actually do it somewhere there, right? And in this case, let's say project an object from that let's say the height of the building is simply the height is simply, let's say 15 in this case meter. Right, so in this case suppose let's say I was standing in this case at that point, right? In this case and I project in this case an object downwards from the edge of the building, and 2 seconds later you project an object from the ground. So in this case, let's say you project in this case so let's say 2 seconds later you project also an object in this case from the ground. Let's say this is object B, and that's in this case object A. So in this case, what will happen is that this object will pass each other at some point. So let's call that in this case point D, right? So suppose let's say this one is been moving downwards, right? So in this case to simply be in this case moving upwards. So again, like I said, at some certain point these two objects will meet. All right, so let's say that let's say this is point A, this is point let's say point B, and let's say this is point D. So in this case, what would happen is that of course this object will pass each other at some point, which is in this case point B. But in this case, what you must note and keep in mind, now this is very important. Now when two objects pass each other, right, and now when two objects pass each other, they would actually have the same height above in this case the ground. So do not forget this. So in this case, when two objects in this case pass each other, right, so in this case their height in this case above the ground would actually be the same. All right, so please keep this in mind. So in this case, what I'm simply going to do would be in this case to label this as X, right? So that would simply mean that in this case this remaining, all right, so in this case that simply mean that that height there remaining there on top, so that would simply mean that in this case that would simply be in this case 15, in this case minus X. So in this case, if I let in this case that position there to be X, so that simply mean that this remaining will simply be in this case the height of the building. So this will simply be the height of the building H minus in this case minus X. But in this case, what you must also keep in mind is that, and remember that we said that in this case we said that at whatever point, right, whatever time ball A has in motion, right, in this case that would simply mean that in this case ball B or object B would be in motion for whatever time ball A has been in motion, minus in this case the late time, right? So in this case that would simply mean that in this case, now remember that we said this case, suppose now remember that in this case you projected this object down here. In this case we said that was in this case 2 seconds later, 2 seconds in this case later, right? So in this case, if I say, now remember that if let's say I'm trying to find out in this case how long in this case it took in this case both of these objects, right? Let's say I was trying to find out in this case how long it took in this case object A in this case to pass in this case object B. So in this case, what I'll simply in this case, let's say I'm also trying to find out how far above the ground in this case these objects were when they passed each other. So in this case, what you simply need to do would be, now remember I said that if in this case you're trying to find out in this case how long, right, how long they took in this case to pass each other. So in this case, what you simply do would be to note that in this case when these objects pass each other, they would simply have the same height right above the building, which you in this case you're going to label X. So in this case, that would simply mean that in this case the remaining there would simply be in this case the height of the building, in this case subtract subtract X. So in this case, now if I now remember that I don't know how long it took object A to reach that point which I label in this case as point, and in this case B, right? Because in this case I would know that in this case object A passed in this case this object in this case at that point. Right, so in this case, I don't know in this case how long in this case it took in this case object A this case to reach this point, but in this case what I can do would be to let that to be in this case. So if I let that to be T, so that simply means that in this case it took object B to reach this point, the time that was taken by object A minus in this case the lead time, which will simply be in this case 2 seconds. So in this case I need you to keep this in mind, all right, because in this case it will be very important in this case when we get to the calculations So in this case, what you simply do in this case, if you're trying to find in this case how long in this case it took object A to pass object B. So in this case, what you simply need to do would be to choose between point A and D, and in this case you collect your data between those 2 points. Why? Because in this case we are trying to find out in this case how long it took this object in this case to get to that point. So in this case, what you simply do would be to choose those points, in this case point A, this case, and point in this case B, and then you simply get the information on those 2 points. But remember, what you must always keep in mind is that when two objects pass each other, they in this case they would have the same height above the building, and the other thing in this case that connects them would simply be time. So in this case, if you let the time taken by the first object to reach where they passed each other to be T, so that would simply mean that in this case the second object took T minus the lead time. So you must keep that in mind. So in this case, what you simply do in this case would be to choose these 2 points, right? You create your first equation, right? And in this case, what you simply do in this case would be in this case to choose now in this case you simply make your first equation in this case using the first object, and in this case what you simply do in this case would be, so that would simply be your equation 1, and then in this case what you simply do would be in this case to choose in this case also point at this point, and where in this case so in this case you would choose the starting point of the second object, right? And in this case where it actually passed the first object. So in this case that would simply be in this case between this case point D and that point B there. So in this case you'd get the information there, and in this case you simply have 2 equations and you'd solve them simultaneously. So in this case my advice for you would be in this case you what I would advise that you would actually isolate X, that, and equate the equations and solve for time, and afterwards when you're done you simply in this case if you were requested to calculate the height or displacement, then what you simply need to do in this case would be to substitute the time back and solve for X. Now let's look at some example so that this actually makes sense a little bit. So we have in this case examples that in this case I prepared down there. So in this case they said that in this case question 1, they said that ball A in this case is projected vertically upwards at a velocity of 16 meters per second, right, from the ground there. And then they say that in this case 1 second later, after ball A is projected upwards, a second ball, which is ball B, is thrown vertically downwards at a velocity of 9 meters per second from a balcony 30 meters above the ground. They say that refer to the diagram, ignore the effects of air resistance. So if we look at 1.1, they say that calculate how long it took both objects to pass each other from their initial positions. So in this case, what I'll simply now remember that these objects in this case were not in this case thrown at the same time. So in this case, what would happen is that as object A, right, as ball A is moving upwards. So in this case, as after 1 second, so in this case, pole B was in this case projected downwards. So in this case, what would happen is that these two objects, in this case, will meet each other at a certain point, right? But remember, I said that in this case, when two objects meet, what they have in common would be their height, in this case, above the ground. So in this case, what you simply do in this case would be, in this case, to label that to be x. So in this case, if this height above the ground from, in this case, where they passed each other is x, so that would simply mean that this remaining height there would simply be, in this case, 30 at the height of the building. In this case, simply be the height of the building, which is 30, minus, in this case, that x there. So in this case, what I'm simply going to do, I'm going to label that point, let's say this point 1, this is point 2, where they passed each other, to be point 2. And in this case, the ground, I'm actually going to label it as point, let's say point, let me just use, alphabet. So that's object A and that's object B. So in this case, I'm going to let this point be point C, this will be point D, and this will simply be, in this case, point E. So in this case, what I'm simply trying to calculate in this case is how long it took, in this case, both objects. Let me just say how long it took object A, in this case, to pass, in this case, object B. Let me just look at it from that perspective. So in this case, what I'm simply going to do would be, in this case, to try to find out, in this case, how long it took, in this case, object A to reach that point D, where they passed each other. So in this case, what I'll simply do in this case would be to choose between point E, in this case, and D. So in this case, what I would simply say is that in this case, between point, in this case, E, and in this case, D. But in this case, what I'm simply going to do would be, in this case, to choose upwards. In this case, it's positive, so that simply means that downwards, in this case, would simply be, in this case, negative. So that would simply mean that, in this case, my velocity initial would simply be, in this case, 16. All right, so in this case, simply be, in this case, for object A. So this would be for object A. So in this case, my V initial would simply be 16, right? In this case, because it was projected upwards, so that simply means that in this case, the V final. Now remember that when two objects pass each other, in this case, the only thing that connects them, in this case, that we would, in this case, kind of predict would be time and displacement. All right, in this case, above the ground. But in this case, what we cannot say is that when they pass each other, their velocity is the same. So when two objects pass each other, their velocity is not the same. So in this case, we are going to leave that, this case, is open. So that would simply mean that, so in this case, if I say that in this case, delta t, so if I say that in this case, it took object A to reach point D to be t, so remember that in this case, that would simply mean that for object B, it will simply be t minus the lead time, which would be, in this case, 1. But in this case, what I'm simply going to do would be to let the time to be t for object A. So that simply means that the displacement, we said that we can let that to be x, right, because it was projected upwards. So if it was downwards, it was going to be negative, but in this case, it simply be positive x, because in this case, it was projected, in this case, x meter, this case, above the building. So in this case, in the positive direction, which is upwards. So in this case, we would know that in this case, our A, or acceleration, simply be negative 9.8. So in this case, what I'm simply going to do would be, now let me just see if I still have, in this case, right, I still have my formula there, thank goodness. So in this case, let me just cut that again. So in this case, what I'm simply going to do, now remember that now I'm trying to look in this case for time, right? Now in this case, what I do not know in this case is, now what I'm simply trying to do in this case is to create an equation, right? But in this case, what I cannot do would be to choose an equation that has final velocity. Why? Because in this case, I don't know the final velocity, in this case, of object A at point D. So in this case, what I'll simply do would be to choose any equation that, in this case, that does not have the final velocity. So if in this case, if we look at in this case, first one, it wouldn't work. Why? In this case, because it has the final velocity. Nor would the second work, but in this case, the third one will work. Why? Because in this case, it doesn't have the final velocity, and in this case, also the fourth one would not also work. So in this case, we can't use that. So in this case, what we simply do would be to use that the third one, which says in this case v, so it says actually delta x is equal to vi multiplied by delta t plus a half multiplied by a multiplied by delta t squared. So in this case, what I'll simply do, I know that in this case my displacement would simply be x equals to my v initial, that's actually 16, multiplied by time, which I let to be t. So in this case, I would say plus a half, multiplied by a, which is negative 9.8, multiplied that by t, by time, which I let that to be t squared. So what I'm simply going to do would be to let that to be my equation 1. So in this case, what I'm simply going to do now would be to create another equation, but in this case using the second object, which is in this case object b. So in this case, what I'm simply going to do would be to say, now for object b, let me just write that. So I would say that for object, let me just use another color. All right, so in this case, this would be in this case for object b. So in this case, I would say that in this case, now remember that in this case, what I'm simply trying to find out in this case would be, in this case, how long it took both of the object to pass each other, right, from their initial position, from where they started. So in this case, my point would be in this case where it started to where in this case where they passed each other. So in this case, the starting point of the second object would be in this case point C, and in this case the ending point would be in this case point D. So in this case, my v initial simply be negative 9, because in this case it was projected downwards, so it would be negative 9. My final velocity, I do not know, vf, I'm gonna leave that as open, right? So in this case, my delta t, so in this case, remember, if it took t seconds for object A to reach that point, so in this case that simply mean that in this case it took object B to reach that same point, in this case t minus in this case 1 second, because they say that it was projected 1 second later. So in this case, this simply be in this case t minus in this case 1. Right, so in this case that simply mean that in this case my displacement, remember that in this case, so that simply be x. Now if this x was let's say 15, so in this case that would have meant that in this case this remaining would have been in this case also in this case 15, right? So in this case my displacement, if I'm looking at this object, was gonna be negative 15. So in this case, what I'm simply going to do in this case, so remember that in this case this remaining height above, in this case below the building, we say that was going to be 30 minus x. So in this case, that simply mean that in this case my displacement of the object B between point C and D would simply be in this case negative, in this case 30 minus in this case minus x. So in this case, that simply mean that in this case my A is simply negative 9.8. So in this case, what I'm simply going to do in this case, now any equation that I must choose mustn't have the final velocity, because I don't know the final velocity in this case of object B when it reached that point D. So in this case, the only equation that is going to work would simply also be the third one. So in this case, what I'm simply going to do would be to say that in this case delta x is equals to in this case vi multiplied by delta t plus a half multiplied by a multiplied by in this case by delta t squared. So this simply be now my displacement, we say that's negative 30 minus in this case minus x, that equals to vi negative 9 multiplied by in this case the time, we say that's t minus 1, so simply be t minus 1, right, plus a half negative 9.8, this case multiplied by this case by in this case by delta, so in this case time simply t minus 1. So in this case, what I'm simply going to do, I'm going to simplify this a little bit. So in this case, what I would have in this case would be so I would have x for that one, let me just use the original color. So in this case I would have x being equals to 16t, in this case minus in this case 4.9 t squared for that one, right? So if I simplify, so that we say that's equation 1. Let me just erase that so that it's simplified. So in this case, what I would have now for this, if I continue with that, so in this case I would actually have in this case x minus 30, right? If you distribute that and you rearrange it, just like to put in the one which is positive first and the number which is negative to be second. So in this case, this simply be equals to negative 90 plus 9 plus so this will simply be in this case a negative 4.9 in this case open bracket. So this is only for that one, but in this case you notice that in this case I can actually open two brackets for this one, so it simply become in this case t minus t there, distribute there. So if you distribute that, you're simply going to have in this case t squared minus in this case 2t plus a 1. So in this case, remember that we are still multiplying that in this case by that 4.9. So in this case, simply become now x being in minus 30 equals to, in this case, negative 90 plus 9 minus, in this case, 4.9 t squared, in this case, minus. Now if you multiply this 2, what you're simply going to get to simply be positive 9.8 t, right? In this case, minus, in this case, 4.9. So in this case, what I'm simply going to do would be, in this case, just to take this 30 to the other side. Why? Because in this case, what I want in this case to do would be to equate these two equations, because in this case, isolating x is a little bit simpler for now, because in this case it has a coefficient of 1, right? So in this case, what I simply do would be to say that in this case x, so let me just simplify this actually a little bit, so that would be 30 equals to, so in this case, if I of course simplify this equation, would be, so this would be 30 minus, in this case, let me just take that 30 to the other side actually, so that you know it's yeah, let me just take it to the other side. So in this case, what I'm simply going to have would be, in this case, x being equals to, so I'm gonna put this first, so simply be, in this case, negative 4.9 t squared, right? So in this case, if I put these two together, I'm actually going to get, in this case, plus 0.8 t, right? No, if I put these two together, in this case, plus this one, so in this case, remember that when it goes to the other side, it's going to become, in this case, 30, right? So in this case, what would happen is that if I add, in this case, if I take 9, in this case, plus, in this case, negative 4.9 plus 30, what I'm simply going to get is actually positive 34 point, in this case, 0.1. So in this case, this simply be, in this case, my equation 2. So what I'm going to say now would be to say, but x equals to x. This is the same x that I have here. So in this case, what I'm simply going to do would be to equate those two equations. So in this case, I would say that, in this case, negative, so that would simply be, in this case, negative 4.9 t squared plus 0.8 t plus, in this case, 34.1. all right, so that's 0.1 there, so that's 1. Let me just, right, I think I'm actually making a mess. 0.1 equals to that second one, which is actually, we say that's 16t, in this case, a minus 4.9 t squared. So in this case, what you can simply note that this t, negative 4.9 t squared, cancel with that. So in this case, what I'm simply going to do would be to collect like terms. So in this case, I'm going to take this one to the other side. So in this case, what I'm simply going to have is simply, in this case, 34.1 being equals to 16 t, in this case, minus 0.8 t. So in this case, what I'm simply going to have there is 34.1 equals to, in this case, 15.2 t. Divide that, in this case, by if you divide both sides by 15.2, what you're simply going to get would simply be t being equals to, in this case, 2 point, in this case, 24 at 24 seconds, right? But in this case, the question was how calculate how long it took both objects to pass each other from their initial positions, right? So in this case, what I'm simply going to say there would be to say that in this case, it took, in this case, a ball A, in this case, now remember that t, in this case, we say that time, that t there would simply be, in this case, for object A, how long it took object A to reach that, to pass, in this case, object B. So in this case, I would say it took object ball A, in this case, 2.24 seconds to pass, in this case, ball B. So in this case, that would simply mean that, in this case, it took, in this case, ball B, in this case, whatever time that was taken by object B minus, in this case, the late time. So this would simply be, in this case, 2.24, in this case, minus 1, in this case, so which is actually equals to 1 point, in this case, 24, in this case, seconds to, in this case, to pass, in this case, ball A. So in this case, this simply be how I would actually answer that 1.1. Right now, I actually took this question from a past paper. Again, I just kind of extracted the one that actually I needed. This case for this sections, for this section. So in this case, so for 1.2, they say that hence determine how high above the ground ball A will be at the instant the two objects pass each other. So in this case, they are now asking for the value of x, right? So in this case, how high above the ground this case object A was when this case when they passed each other. So in this case, that simply be that x there. So in this case, what I'll simply do in this case, now remember that I already know in this case I already know the value of t of time. So in this case, what I'll simply do now would be to say that x, I'm going to use actually the first equation. So right, so in this case x will simply be in this case to 16 t, this case minus 4.9 t squared. So in this case I found t to be in this case to be that 2.24. so in this case simply be in this case 16 multiplied by 2.24, in this case plus that's actually a negative 4.9 multiplied this case by 2.24, right, in this case squared. So if you put that into your calculator, what you're simply going to get as the value of x is simply 11.25 meters. So in this case, this simply means that in this case object A was actually at in this case 11.25 meter above the ground when in this case when these two objects passed each other. Now if I were to draw in this case a velocity versus time graph for these objects, in this case when they met or when they passed each other. So in this case I want you to kind of look at the at the graph that I'm actually going to produce. They simply it's still the same graph. We say that in this case the velocity versus time graph always form a straight line, but in this case let me just draw that so that you see the type of graph in this case that you are simply going to have right now. Okay, that's not good. Okay, I think that's fantastic. So in this case, now remember that of course this simply be in this case a velocity, right, in this case in meters per second. This will simply be in this case delta t, in this case in seconds. So in this case this will simply be the velocity versus in this case versus time, right? So in this case remember now that in this case object A, so in this case if I'm drawing a graph in this case velocity versus time graph of motion for both objects, in this case from where they started to where in this case where they passed each other. So in this case that would simply mean that in this case object A in this case it started in this case with a velocity of 16. So in this case it will start from that point there, all right. So in this case it will start in this case from that point, but in this case, so in this case it will start from that point in this case until of course it passes object, let's say object B, right? So in this case let's say it was at that point there. So in this case simply be this is for ball A. So in this case this simply mean that in this case this is, so this is the velocity at that point, that starting point would simply be in this case 16, all right. Right, so in this case that simply be in this case 16, but in this case for object in this case B, now in this case remember that object B was projected in this case 1 second later. So in this case the velocity versus time graph for object B is not actually going to start in this case at that it's not actually going to cut the x-axis. Why? Because in this case that second object was actually projected 1 second later. So after 1 second, so in this case my graph would simply start from that point. Now remember that in this case the velocity initial of that object B was actually -9. So in this case it simply started at that point. It won't touch the y-axis, and in this case it would go that direction until of course at that point when they pass in this case each other. I just hope that would be perfect. Right, so in this case let me just try again. Right, so in this case this is when in this case where they pass each other, in this case a time which is in this case 2.24. so in this case for so in this case it would be in this case for ball B. So in this case, now note that in this case for object B it would not actually start in this case, it would not actually start in this case at t0. Why? Because in this case this second object was actually projected 0 in this case 1 second later. So in this case this was actually projected in this case late, right, than object A. So in this case, if I'm able to draw in this case the velocity versus time graph of these two objects on one in this case on one Cartesian plane. So in this case, the second object will not actually start at that point, but rather in this case it will start in this case when time is actually 1 second, which is at that point there. Now note that in this case the final velocity of these two objects are actually different. So you note that in this case for this one, so in this case actually no, that will not actually be that one. Let me just erase this. Actually made it to that. So in this case for the second object, right, so in this case remember that this was actually projected from the height of the building. So in this case, as time progressed, its velocity was actually increasing, that in the opposite direction. So in this case, its graph is actually going to be in this case a negative one, right? Because we chose downwards as positive and negative anyway. So in this case, this is the time of graph that I'm going to have. Now again, it's still the rule is still the same. So in this case, they're not actually. So the second object is not actually going to start in this case it's not actually going to cut the y-axis, right? So in this case, that's one thing in this case that you must keep in mind. So in this case, this is where they made, right? So in this case, this would be in this case a 2.24. So in this case, this one actually started in this case after in this case 1 second later. But in this case, what I also wanted to project to you is that in this case the final velocity in this case of the object, in this case when they pass each other, in this case they're actually different. So in this case it will be the velocity of the object at point D, which is unknown. So in this case this will simply be in this case the velocity of object A, of ball A. So this is for ball B. In this case the velocity for ball in this case for ball A at that point D. Say those. So in this case the velocity of the objects when they pass each other is not the same. Now there's another question down there which I'm being attempted in this case to do as well. All right.